eye level, mapping at the human scale to solve AGI. So we're going to zoom out for a moment, because if we're serious about artificial intelligence, machines won't just need data. They're going to need deep spatial understanding of our world. And this is what we're going to discuss in the upcoming presentation. Ladies and gentlemen, let me welcome to the stage the founder and the CEO at Mosaic, Jeffrey Martin. Jeffrey, join me over here. Welcome.
Hi, everybody. We have more Gaussian splats for you. So, I know a few of you people here. Some of you I've known for a very long time, and there are a lot of interesting, great people that I'm meeting for the first time here. Some of you know me as an experimental photographer. Some of you know me as person running Mosaic. We make geospatial camera systems for capturing scenes like these. So, for the past few months, I've been thinking a lot about how what we're doing intersects with what other people are doing, especially in the space of AI, and of especially the AI that is not the LLM stuff, but the other stuff. We call it world models. There are generally a couple different things that we mean when we talk about world models, so I just want to clarify. I'm not talking about generative video like Sora, or even about things like Marble from World Labs, which is a kind of immersive type of deal. I'm talking more about things related to embodied cognition and what allows our minds to develop and function so well using remarkably few resources and so little energy. Just put it into context, a rat brain has maybe 200 million neurons and maybe a trillion synapses. GPT-5 has, I don't know, 350 billion parameters or something like that. It's not apples to apples comparison, but basically, even a rat brain is tiny and can do things that we haven't figured out how to solve. Like, nobody in the world has figured out how it is that the brain of an animal, without using language, is able to perceive, think, and act in the world in remarkably sophisticated ways. So that's what I have been studying over the past few months to try to understand better. And people have been thinking about this for a long time. For well over a century, people have been trying to figure out, like, you know, what it is our mind does, what do our eyes do, what exactly is going on. You have a baby who can do nothing, and then they eventually recognize faces, they have object permanence, they understand gravity, they understand physics to the extent that they can throw things and understand where they're going to go. So there's something extremely sophisticated going on. And there are a lot of theories that are, pretty plausible by now. So I would like to get into those, and then I will get into how that intersects with what we're doing and what we're looking at here. Hermann von Helmholtz, he invented the ophthalmoscope, which is a machine for looking into the eyeball for ophthalmologists. He said, the sensations of the senses are tokens for our consciousness. It is left to our intelligence to learn how to comprehend their meaning. So this was in 1867, so already someone is proposing that we're not actually seeing the world, we are using our eyes to see something, and then our brains are turning that into the thing that we perceive. And I think everyone's heard this idea before. Probably isn't very new, but it's really important. So fast forward to 1963, we're experimenting with kittens. So we've got, these kittens were harmed. Well, the one on the left was. So we've got two kittens in a carousel, and one is walking and able to use its body, and the other one is kind of tied up, bundled up, and is not using its body. So as the two kittens walk around, they both see the same thing, but one of the kittens is not using its body to correlate what it's seeing. And what happens is that the visual system of the kitten on the left doesn't develop. The kitten on the left is functionally blind. Its eyes work, but they're not connected to the rest of its brain. So it's functionally blind. So there's something going on where the eyes aren't the whole story, but they're connected to the body, and there's a process going on which requires the body for the eyes to actually work. So generally the idea is that the brain is not recording, the brain is not doing this 3D reconstruction of the world all the time and then building up this model that we use to interact with the world. This is almost certainly not what's happening at all. There's very much a top-down, you can call it hallucination, you can call it an assumption. There's a top-down kind of idea of what we think is happening all the time, and we're only using our senses to do some error correction, and we're acting as a part of this error correction in order to understand what's really going on. So action and perception are really sitting right next to each other. There are a lot of optical illusions to sort of show this. We get a lot of glimpses into what we think is happening from optical illusions, from people who have brain damage, from people who have other conditions such as schizophrenia, autism, things like that. This is a very classic optical illusion. I'm sure you've all seen it. It doesn't matter how many times you look at it. Square A and square B look different. They look different, right? They're not different. They are the same. Like, I promise you they're the same. And it doesn't matter how much you understand the fact that they are the same color, they look like different colors, and that's because your brain is just giving you this top-down, fairly reasonable assumption, and it, almost all the time is correct, that square A and square B are different colors, because you know what a checkboard is. You've internalized it deeply, and that's just a fact, and it really doesn't matter how many times you see this. There's other optical illusions like remember the blue dress, gold dress internet thing some years ago. There's the hollow face illusion. There's a lot of optical illusions that kind of could give you a general idea that your brain is in fact making some very heavy predictions all the time. And even when your senses tell you that it's not that way, you still sort of see it that way. So this classical idea of there's the world, you sense the world, and then your brain assembles it, this is probably not right. So you've got this cycle. Your brain's generating predictions. That is the main job of your brain. And this is much easier, it's much simpler, it's much less resource intensive than this bottom-up generating an entire picture of the world. You're generating predictions. The world delivers signals that confirm or deny what's going on, and these prediction errors go back to the brain to give you the hopefully true picture of what's happening. The whole thing is hierarchical, so the system learns its own priors. You've got priors that are these kind of basic ideas of what's happening, and you've got precision weighting that decides what errors matter most. Sometimes you can just discard most of the information that's happening. In fact, most of the time, most people are doing that. If you're driving home on a familiar route, you're not really needing to pay much attention at all to what's going on. If you're driving on a foggy night on an unfamiliar road, you're probably really tired afterwards because you have to pay such extreme attention and actually reconstruct. What's going on is that we've got this loop that uses the same neurons. We've got perception, attention, and action. When you imagine something, you're often using the same neurons as when you're doing it for real, and this has all been studied quite extensively. Action is not a response to the world. Action is how you select the next sample of what you're doing, and therefore what you're thinking about. So generally, you can't really remove the body, the self, from this mechanism. If you try to build a brain in a jar, it's not going to work, just like with the kitten. If you take away the ability of the kitten to use its body, its eyes don't work. So the body is very, very central to the way we're able to use our minds. And also, the world itself is part of that. You can't really take away someone's body or the world outside and expect a mind to develop. They're very much connected to each other, which is generally not how a lot of robotics and stuff like that is happening, or how AI is being solved right now. We're sort of trying to take the mind and put it into a world without having them develop together. So when we're talking about solving world models or solving embodied cognition, I'm talking about how can we build a machine that can act and perceive in the world the way we do. You probably need some training data, and the available training data, like, okay, let's take YouTube. YouTube's got like, I don't know what, 1 billion hours every hour is being uploaded or something like that. It is, extensive and it's quite a staggering amount of content, but it doesn't have a lot of stuff that could be pretty useful for training these things. It doesn't have any kind of geometric world truth. It's not multimodal, it's not time-synchronized. It's sometimes captured at human scale, sometimes it's not. Sometimes it is not moving the way the body moves, and it's not really coupled to a person in any way. So what we're thinking about here is how to build capture devices that come closer to this kind of data, which I think is going to be very important in the next step of solving this aspect of AI. So what am I doing here, and who am I, and why am I talking about this? So I went through my photo collection and found all the pictures of me over the years. You can see by the lack of gray hair how long I've been doing this. I've been building various types of cameras attached to bodies, creating human scale data for a very long time. So the first pictures from 2008, I think. I showed this at a Panel Tools conference. A couple of you in the audience were there for that. So I'm not an electrical engineer or a software engineer. I just someone with persistence in building a human body scale camera system that can capture the world. So this turned into a project called SphereCam in 2015, 2016. Some of you are familiar with that project. It was a small VR camera, and that morphed into Mosaic, which is who we are today, and we've shipped cameras to 50 countries worldwide. Our cameras work really well. We have a lot of very happy customers doing geospatial and 3D data collection for many different applications. So about the training data, about how to build robots and how this is going to come about. One of the co-founders of World Labs observed that robotics doesn't have a large repository of training data. It's not like LLMs. LLMs had all the words already there. We had trillions of words just there for the taking. That's not the case for this. So that's why I would like to show our next product. It's shaped like a body because the body is the best shape, and it's great for capturing data at the human scale. This is not the same as the amazing Gaussian splat data sets that we've been looking at that were made with giant professional cameras. This is more, we can build 1,000 of these and walk around and capture synchronized, multimodal, multi-sensor data that can make these amazing Gaussian splats that I showed you earlier. But it is with the idea that this can be part of building large data sets that can help to solve the next chapter of AI. Thank you very much.
Thank you so much. Thank you so much. We've got the questions from the audience. Thank you so much. So let's tackle them. The first one, you talked a lot about how to understand our minds and brain. So can you elaborate on how understanding our minds can help us improve scanning?
Well, I think it's maybe the other way around. I think scanning the world at scale in the proper way can help us unlock this mystery of the mind, which, to be clear, it's very much unsolved. I outlined some theories about the mechanisms, but what exactly is happening and how we can replicate that, we still don't know. But what's definitely really important is the visual aspect. This is extraordinarily important for any animal that doesn't use language to understand the world and do sophisticated things. So I think it starts with scanning to help us understand the mind.
Thank you so much. Question about your solution. So where does your product stand against competition like experts? What is your unique selling point?
So I don't want to go into a spec war or anything like that. Experts is a fantastic product. They have a good and enthusiastic user base. They have a good post-processing pipeline. This device is for larger scale types of captures. So it incorporates RTK, PPK, LiDAR. It has 6 global shutter cameras with 1-inch sensors and great optics. I would say that would be the hardware specification-wise, the biggest difference between a system like X-Grid is that the cameras themselves are quite a bit more higher spec and sophisticated. And this could be for that, for the reasons that I was outlining before. I think it could be very important for this type of training data. For generating Gaussian splats, I think it can help to generate maybe a higher level of detail if that is necessary.
Cool. Let's take a look at one more question. How do you see enterprise systems of record influencing hierarchical prediction system? Can structured GIS context support AI reasoning?
Oh, thank you, Arkady. I think so. I think generally understanding the world as you perceive it and getting priors that are, priors are basically like beliefs that you have, which are hopefully true. So if you are able to kind of inject this knowledge into an embodied creature or machine, I think that probably can help, yes.
Thank you so much. Last question, how heavy is the backpack or the product, and how much does it cost?
The backpack is, I think it's about 5 kilos. It seems to be about as heavy as my daily carry backpack when I have a laptop and a camera in it. you're welcome to try it out later. It costs similar to our other camera systems, so it's kind of an enterprise pricing.